yeah, please sign in if you haven't. There's this QR code. Give like about a minute, but we'll also have the sign-in form later. Coolio. All right. Also, let me know if the volume is good. I know sometimes the music can be too much. Okay. All right, so here's the agenda for today. We're going to first start off with like general basics about each of the programs, talking about, if you've never seen this program before, how do you get started modeling things? After you learn the basics with our hosts, we're going to present a little challenge thing for you all to try and complete. It's going to be super fun and put your newly found skills to the test. We'll have an opportunity for folks to share what they've made. And if you want to share, we'll also potentially be posting what you end up creating on the AIChE Projects website, which is super exciting. And we hope you choose to participate. And at the very end, we're just going to close it up with a little bit of Q&A. Asking any general questions you may have about either software, its applications, or maybe further jumping off points for learning. All right, that is the general agenda. Just gonna really quick introduce our presenters and hosts. We have Animesh and Arturo. They'll introduce themselves more in detail in their respective rooms, but Animesh is going to be doing Fusion 360 and Arturo is going to be doing SolidWorks. So there's kind of two concurrent workshops that will be going on at the same time, and then later on we'll all meet up together for the little challenge thing. All right. I think that is it. Anyone have any questions about logistics or anything like that before we go into breakout rooms?
Assuming that's hopefully enough time for you guys to have you should have downloaded it before, but opened Fusion and also grabbed a mouse if you weren't able to do that earlier. All right, wonderful. I will now begin sharing my screen. Actually, I'll just share my whole screen. We'll see how that goes. Okay, can someone give me a confirmation that you guys see my Fusion 360 thing? Okay, wonderful. I see thumbs up. So I'm going to assume that all of you just downloaded Fusion and opened it. So the first thing we're going to start doing is by setting up our units, because we're in the United States, so we use units that no one else in the world uses. So yeah, so you're going to have, so Fusion is kind of finicky because it is a cloud-based thing. It allows you to work across, it's basically like Google Drives for CAD. But it makes it a bit finicky for units for that reason, because let's say you're collaborating with someone in another country, they might be using different units. So you have to actually set the units for all the different types of files individually. And here's how you go about that. On the top right, you're going to see your initials. So for me, it says AM. It's right below like your exit thing. Don't click on the exit, click on your initials. Left click on your initials. And then you're going to see Autodesk account, and then you're going to see preferences. So click on your preferences and give it a second. And then you should get a window like this. It looks scary, but we're going to ignore most of it. Over here, it's going to say default units. That's going to be the units which Fusion starts off with whenever you open up the program. But yeah, like I said, we're going to have to set the units for all of these things individually. So click on design and then default units for new design, change it to inches from whatever else it comes in by default. Okay, hopefully that's enough time for you all to do that. And then click on electronics. Although we aren't doing any electronics, it's just better to set all these things up at once so that you aren't confused later. And then default grid unit, set that to inches. And then default grid unit for new board, also set that to inches, right? And finally, manufacture, that should also be in inches. And I don't think, oh yeah, and then I think simulation and generative design, also go ahead and set that to English with inches. So once you have done all that, so all of these should say inches, go ahead and press apply, and then press OK. Now, the thing is, the default file that Fusion opens up, the first time it opens up, unfortunately, doesn't actually convert it. So over here, click this little down arrow and click on, it says units, inches over here. Then if you click on that and then click like this little notepad, set unit type to inches as well. And for you, it will change, and then press OK and set as default, of course. All right, now we have gotten our units set up, but like I said, Fusion is cloud-based, which means there's a little bit more setup to do. The distinction in Fusion between the two main types of, two main types of drives you have are shared and owned by you, right? So if you're working on some project, like I am working in AWT, when I click my name over here along the top left, it'll say teams you're a member of, AWT. That's because someone added me to that team. But under single user storage, it should also say your name. For now, all of you are just going to be single users, I assume. So just make sure that it says your name along the top left. But even within your name, there's some distinctions. So there's all projects pinned, owned by me, and shared with me. So shared with me projects are those which someone else owns and they shared with you, but you guys aren't in a team. So the Google Drive analogy to this would be when someone shares a document with you, but you guys don't have a shared drive together or whatever. So yeah, and then make sure you're in the owned by me section. Cool. So I'm gonna assume everyone has their name up here and it says owned by me over here. And then go ahead and click a new project. So a project, in analogy to like Google Drive again, it's like a folder. So over here, we'll just call this, I don't know, AIChE workshop. Okay. So go ahead and press enter. Give it a second because it has to sync everything. And then if you double click on your AIChE workshop, it should go to a view like this. And over here, you can upload CAD files, which you already have, but we aren't going to do that. We're going to be creating everything from scratch. All right. So my goals today for you guys are to be able to make like a basic thing and combine multiple basic things into like one assembly, right? So the biggest difference, I think, between Fusion and SolidWorks will be that the way the assemblies work. Because in SolidWorks, assemblies are like their own kind of file, but I'll talk more about that later. All right, so once we're here, you're gonna click this little paper icon and then click New Design. And it's going to be in this view now. So we're gonna go ahead and save this, so press Control S, and we're gonna call this Thor's hammer, because that's what we're going to be CADing for our practice. So Thor's hammer. Go ahead and save that, and the name along here in this like I guess ribbon they call it, it should change to Thor's hammer V1, right? And the neat thing about Fusion is as it updates, it actually adds the V1 initial, V2 initial on its own. So if you're working in a team, it's very, very easy. Cool. Now we actually need to start making something. And the general principle I'm going to show you guys is how to take something from, like a two-dimensional thing, such as a sketch. Imagine like you're in the cartoon world and you just see things in 2 dimensions. So I'm going to show you guys to draw something in 2D and then to move that up into 3 dimensions, right? And that's just the most basic and easiest way to do this because it makes intuitive sense in my opinion. And for Thor's hammer, we're gonna first CAD like the hammer part, like the bulky hammer, and we're just gonna assume that it's basically a cube. And then we're gonna CAD the handle, and then we're gonna CAD some sort of ornament for the handle. So that's our plan. So let's get started with that. All right. So like I said, first we're gonna CAD the head of Thor's hammer. So if you haven't seen it, this is what Thor's hammer looks like. And we're just going to use these measurements because I I don't want to like figure out what it actually is. So it says that Thor's hammer is 22.7 inches by 6.5 by 6.5. So yeah. And when I learned CAD for the first time many, many moons ago, my teacher showed it to me with starting everything in the top view. What that means is we're going to be looking at our two-dimensional sketch as it would appear if I was like looking down at it from the top. So yeah, what you're going to do is click this top along the cube. So this is like your orientation cube. And when you click this top, nothing should change apart from this cube should move. So then we're going to make like our sketch. Our sketch is what we would see from the top if we were looking down at it. And like I said, we're just going to treat this as like a very simple rectangular prism. So you click on sketch and then click on this like beige rectangle. And once you do this, I don't know what that symbol is called, but it's on crash test dummies. This symbol should appear and there should be a white dot in the middle of it, right? And if you look at like a rectangular prism or a cube from one face, all it looks like is a rectangle. So we're just going to draw a rectangle. And I'm going to assume that the measurements from that like graphic card I said, you know, they went height, length, width. So the length and the width, they are 6.5 inches. Oh, so I pressed enter. So that's why my my thing like went all it's stretched. But I want to move my camera view up. So what you're going to do is you're going to click on this little hand over here. It's called pan, and click and drag like you would if you were doing like I don't know. I think it's the same with like paint and stuff. So if you click and drag, you can like move your picture around while staying in the same plane. So yeah. And well, we want 6.5 by 6.5. Right now, one side is 6.5, but we don't know what the heck the other one is. So we're going to click on this thing over here called sketch dimension. That's going to set the dimension for the other side. So go ahead and click that other side. It should turn like dark blue when you click it. And okay, so it's 1.7, but we're going to press, we're going to click on that, and then we're going to set this side to 6.5 as well. Right, so now we have a rectangle. I mean, that's not exciting, but I will technically have a square, but whatever. That's not that exciting, but does everyone have a square or a rectangle? I don't see any complaints in the chat, but okay then, no one's voicing. Oh, also feel free to interrupt me if you guys have questions in the middle. It just works better that way. So there don't seem to be any questions or complaints. I'm going to assume all of you have successfully made a rectangle. Now, once you have your rectangle, we're going to dimension. We're going to make it like tall. We got to add our third dimension to it. And according to that playing card or whatever, the third dimension was 22.7 inches. So to do that, we're going to click on solid. So we were under sketch. Now we're going to click on solid. Then we're going to click on this extrude. This is going to like stretch stuff out in the third dimension. And this should automatically become dark blue or blue. And this number over here, which my cursor is flashing over, that's going to be the height. And that was 22.7 inches. Right. Now, it should turn dark gray once you press enter after typing 22.7, right? But right now you're thinking, well, what actually changed? Well, I'll tell you. Right now we're just looking at it from the top view. So we saw height increase in the top dimension, and you don't notice that. So what we have to do is we have to rotate our camera, and there's a couple of ways to do that. My preferred way is to press this orbit, and then you're going to have this like cool looking figure on your screen. And then if you press down on your cursor wheel, like a button, you should be able to move it around, right? And if you zoom out by scrolling like towards you, it might be a bit different like the camera controls, but if you get lost ever, just press home and there you'll see what your shape looks like. So yeah, wonderful. We now have like the very basic, like the head of the hammer. But we want to do more stuff with this, right? We want to be able to like slot our handle into it and everything. So what we have to do to slot our handle is to make, like in real life, you can imagine you would be drilling a hole and then you would like screwing your handle into it or something like that. But this is CAD, the world of CAD, so it's a lot simpler. So I'm going to go to the right side. So I'm going to click right on my cube. And if you're lost, just press home and then press right on your cube, and then you'll end up here. And I want to make a little hole for my handle to be put into. And to do that, I'm going to click on my on the face, on the gray face. So double click on it, and then click this Create Sketch. And then a beige rectangle should appear again. You can either click on there or you can click on the object on the face itself. It doesn't really make that big of a difference. So what we're going to do is we're going to make a circle in here, which is which is basically going to be for our handle. So click on that, and then you should have clicked on the circle. So click on that and then drag it out. And we're going to assume that our handle on the outside is going to be 3 inches wide, right? So yeah, so make it 3 and then press enter. Well, right now we have a circle, but we don't really know like where it is. Like it looks kind of off center or something, but don't worry, you can fix that easily. So click on the center of the circle, and I want to like make sure this is entirely centered so that Thor doesn't have balance issues or something. And I'm gonna click on let me show that again. Delete that. So click on the Smart Dimension tool, and click on the center of your circle, and then click on the right edge. And a number should appear. Mine says 3.5, you're just gonna say whatever. But we want this to be exactly in the middle, and remember each side is 6.5 inches long, so we want this to be 6.5 divided by 2. So you can actually just enter it in as like an arithmetic equation. So you can do 6.5 divided by 2. And then you don't have to do the parentheses. I actually don't know why I did the parentheses. I think it's just habit from like Excel or something. But yeah, so you do 6.5 divided by 2. And if you press enter, it should now be 3.25, which means it's exactly centered in the left and right direction. Has everyone gotten to here? Do you guys have like a gray pillar, and then do you guys have a circle which is centered in the left and right direction? If there's any questions, speak up, or you can put it in the chat. I did not see any. All right, then I will go on. Now, we're centered in the left and right direction, but we still aren't centered in the up and down direction. So we're going to repeat what we did for the left and right, which were the up and down. So I'm going to click on, take my my sketch dimensions. I'm going to click the center. And then I'm going to click over here. Oh, whoops, I actually unclicked my center. So I'm going to click on my sketch dimension, click on my center, and then I click there, and then I should get some number. And remember that our height was 22.7, so this should be 22.7 divided by 2. And you should get 11.35 over here. So now our hole is like perfectly centered on our cylinder. But now we have to like actually make it a hole, so we have to like bore into it. So we're going to use the Extrude tool again, just in a different way. So we're going to click this, and instead of making the value positive, which would mean it would be coming out at us, we're going to make it a negative. And I'm just going to say that it's -1 because that makes life easier. So the depth of our hole is going to be 1 inch. That negative is just specifying that it's going away from you, right? And then -1, and then enter. And if I do that, look at that. But right now I'm using my orbit tool by pressing down on my cursor wheel, mouse wheel. And see, that's that, yeah. Now this is just the hammerhead. I'm not going to show you guys like how to make these edges curved and stuff because like there's not much time. But I'm going to go ahead and save this, and just press Control Save, and then it should save the version description user saved. Yeah. If you guys work in a company and they like actually make you change that, do that. Don't just like make everything user safe. They'll get angry at you. Okay, so we have made like the head of the hammer. but we still need to make like the handle and like some kind of an ornament for a handle so that core can look cool. So we're going to make a new file for the handle. So click this, the paper, and then click on the new design, and it should open up something. And before we start work, we're going to save this, and we're going to call this Core's Hammer Handle. So it should be in the AIChE workshop folder or project, which we created earlier. So go ahead and save it. Wonderful. And as for the handle, we're basically going to pretend that it is a basically like a pipe, like it's a hollow cylinder. And to do that, we have to make one circle. Imagine like my fist is solid, then put like another thing over, like another circle, and like kind of bore through it, like we did with the handle hole, but this time we need to go all the way through. It sounds more complicated than it is, if I'm honest. So we're going to repeat what we did last time. So we want to start in the top view. That's just because someone taught me 6 years ago, and I'm going to tell everyone that. So click on the top view and click on the create sketch. Good. And then click on this beige rectangle. And then there should be the crash test dummy and a white dot, or crash test dummy sign. So then click on your circle. And as a matter of habit, I always draw the outside diameter of my pipes first. And that's an important distinction, because if you think of a pipe, the outside diameter is one thing, but the inside diameter is another thing. So we're gonna draw the outside diameter first. And if you remember, the hole for our handle was 3 inches. So the outside diameter is also going to be 3 inches. Nice. And then if you remember, we have to draw another little circle inside it. So we're just going to stay in the sketch. And this is going to be like the hollow of our pipe. So that area in the middle. So I'm just going to click here. So this area is actually going to be hollow. And this part is going to be the, the thickness of our pipe. So yeah, so I'm just going to press Control Z to redo that circle nicely. And I'm going to see that the inside diameter is 2.5, because that just makes the numbers easy. So the inside diameter is 2.5, and the outside diameter is 3, which means that this wall, like over here, that should be 1/4 of an inch thick, and I'll show you guys how to measure that. But I'll show it to you once we've already made it 3D. So to make it 3D, we're again going to use the Extrude tool. So click on Solid, and then click on your Extrude tool. And I have arbitrarily decided that the handle should be 18 inches long. So enter 18 so that it comes towards you. And press Enter. And you should have a cylinder of sorts, right? So you have to zoom out a bit. So to zoom in and out, you can scroll in and out. So yeah, there it is. But I told you guys earlier that I would show you how to verify that the thickness of your wall is actually what you think it is. So to do that, we're going to go to our top view again, zoom in a bit, and we're going to click on this thing. It looks like a tape measure or a ruler. Click on that. Click on the inside diameter to highlight in black, and then click on your outside diameter. And it says minimum distance is 0.25. And it also says that over here, it just like goes super squished because of the small size. So yeah. And now we know that our thing is actually what we thought it was. So I'm going to press home again. And I'm going to close this. And wonderful. So this is just our handle, right? But remember, I wanted to make some sort of ornament for the handle because Thor needs a cool hammer. But the challenge is, do we just design the ornament directly onto this piece, or do we design it as a separate piece? I always tend to make things in as many pieces as I can. And I'll tell you why. So in the team that I work in after water treatment, we often, we have like different pipes and stuff. We have like elbows to join everything together. but our most complicated part is our ion exchange column. And you need like a very strange series of connectors to connect an ion exchange column to a pipe. But what happens is once in a while, we need to change the connectors. But in my CAD, if I design everything as one piece, the only way I can change like one little connector is by like changing the whole column. And that is very annoying. I can tell from experience, right? It's like if you needed to fix like a small part and for that you need to like take your whole car apart. It's not helpful at all. So what I like to do is I like to make things in as many little pieces as I can so that I can change one without affecting the whole assembly or the whole thing very much. So what we're going to be doing is we're going to be designing the handle. Then in a separate file, we're going to be designing our ornament. And after we design our handle and ornament, we're going to combine them to have like one assembly of handle and ornament. And then we're going to combine the handle ornament assembly with like our hammerhead. So that's the plan right now. Okay, I'm at 6:33, so I see I have like 15-ish minutes to go. And let's do the ornament. So create a new file. You can either go through this process again, so click on the paper and new design, or you can just click the plus over here. So yeah. So we're going to repeat what we did. I'm going to go here. And for my ornament, I'm thinking of, I don't know, I want like something circular so that it can attach nicely to the pipe, but I also want like an interesting shape on there. So we're going to do like a circle on a triangle. That sounds difficult, but I'll show you guys what I mean. All right, so we have clicked our top view. Then we're going to go to our sketch, right? And when we're on our sketch, we're going to click on the beige rectangle. And I said I wanted the base of my ornament to be a circle. So that's what I'm going to do. And I'm going to set this to have the same diameter as our pipe. So this should be a diameter of 3 inches. And I'm going to zoom out a little bit. So 3, wonderful. And I want to show you guys a new process so where you can like draw multiple things on one. So I go up and click on the solid. And once you have this, and extrude your circle. And we're going to say that this is like, I don't know, 0.5 inch thick, right? So if I press my home button, you can see that this is like a hockey puck. So yeah, then go back to the top view. And this is now considered an object. So you can draw on this itself. And on this, I want to have like a little circle puck thing rising out of it. I'll show you what I mean. So click on your blue face, like we were doing with the other, like we did with the first hammer. And then click on this, and then click on your gray area. Good. And now I want another circle. And the diameter of this circle is going to be 2 inches. And I'm going to extrude this as well, so it sticks out. So I'm going to click on my extrude tool, and then I'm going to click on this inside circle. And I'm also going to make this stick out 0.5 of an inch. So you might not be able to tell from this view, but if you go to your home view, you should see something like this. It's like 2 hockey pucks on top of each other, like a really small wedding cake. Anyway, go back to your top view. And I said I wanted to have interesting shapes. So I said earlier I wanted a triangle. You can do that. Click on this, like click on your inside circle. It does look like a Lego stuff. Yes. And so click on your, the top hockey puck, and now we need to make a triangle on it. So there's a couple of different ways you can do it. Like there's like directly a tool which will make a triangle here. I just gotta move like the zoom toolbar. It's kind of in the way right now. So if you click on this create, you can create a polygon, and well, they used to have a triangle in here, but we're just gonna make a triangle by joining like 3 lines together because that's easy. So to do that, I'm going to, so in your sketch, go to the line, and I'm going to have my first line over here. And I'm going to have it go to the corner, then another line from this end to this end, and then a third line from here to here. All right. Now, we have drawn our triangle, right? Everyone should have a triangle like drawn onto their figure or onto their hockey puck looking thing. And then now we need to make this 3D. So we're going to click on solid, and then again, we're going to click on extrude. We're going to extrude it. What should we do? Let's make it 1 inch. Okay, now when you zoom out, you should have something which looks like this. I think this is pretty ornamental. I did not worry too much about the dimensions for the triangle, but if you want to, you can edit it. Actually, I'm going to take this as an opportunity to show you guys the timeline feature on Fusion, which is actually very new. So if you look down along the bottom of your, I don't know what this is called, the bottom of your, it's right below your camera options, but they call this the timeline. And when you click on some components, so let's say go to the sketch, and it'll light up where it's drawn and what is drawn, right? So that's what, so the triangle down there is what's drawn, and that's where and the blue part is where the triangle is drawn. And if I drag this like bar over here, then every step you did before disappears. It's kind of neat, huh? So what this actually allows you to do is make some cool time-lapse pictures. So if you click on, I need to make this full screen. So if you click on this play, you can see yourself catting, which is so exciting, isn't it? So yeah. So I want to show you guys how you can make edits. I'm actually realizing my triangle is a bit crooked, which is unfortunate, but we can fix it easily. So what we're going to do is we're going to edit that sketch. So we're going to right click on sketch and then click edit sketch. Okay. And to do that, I'm going to do some quick smart dimensioning. And let's see if we can make this an equilateral triangle. So click sketch dimension, then click on your bottom end, and then click on the left side. And this angle, currently mine says 55.8. Let's make that an even 60. And I want to repeat that with the other end. So I want to repeat that with this end and this end. I want to make that 60. And now look, Fusion fixed my triangle for me. I'm sorry, I just had to, if you guys have taken Sen 15 or Nano 15 with Dr. Labari, you guys know how he gets very excited and MATLAB does exactly what it's supposed to do. That's how I feel. So yeah, now we have a lovely equilateral triangle over here. And if you guys don't trust the geometry, you can ensure that the side is also 60 degrees by clicking inspect, then clicking one side and then clicking the other. And hey, that is 60 degrees. So geometry has held true just as it has for previous centuries. And then I'm going to click on finish sketch. And now if I zoom out, look, my triangle has been fixed. Thor will have a good ornament on his hammer, handle. So yeah, all right. So you guys should have an ornament of some kind. If you guys are adventurous, you guys can like make your own ornament. So yeah, but oh man, I never saved this. It's horrible. So I'm gonna save this. Control save, and then I'm gonna call this handle ornament. I'm gonna click on save. And along here, everything that I have made so far is living happily, right? And now we need to start joining stuff together. Like I said, what we need to join together first will be the handle with the handle ornament. So we're going to do that using a new file. So click on File, New Design, and let's save first and call this handle with ornament. And make sure it's in the AIChE workshop folder or project. Nice. So this time, we're not going to start by going to the top view. This time, we're going to start with a different step. So if you guys remember, way in the beginning, I was talking about assemblies are different in Fusion 360 than they are in SolidWorks. So now I'm going to expand on what I mean by that. So in Fusion 360, you can put stuff into any file and start calling that an assembly. But in SolidWorks, oftentimes you have to create an entirely different kind of file for assemblies. Both have their advantages. So in Fusion, the advantage is that you can still edit stuff in an assembly like you would be in like a regular design file. But SolidWorks' advantage with assemblies is that the files are physically smaller, like they take up less space. And also that allows SolidWorks to offer you like more editing features in their assembly files. But, you know, a lot of those editing features, a lot of people never actually use unless you're like working in a company doing CAD or something. So yeah. So the first thing we're going to join together is the handle ornament with our handle. So I'm going to click on the Thor's hammer handle. So I'm going to right click on it, and then this menu should pop up. And what we want to do is insert into current design, right? Insert into current design. It'll take a second, and it's very zoomed out, so you can't see it right now. So we have to just click home. Where is it? Where's my file? Huh. Oh, I know what happened. I never saved this. So after you finish each of your drawings, you have to press Control Save. So I'm going to press Control Save on my Thor's hammer handle file. And look, once it pops up over here, you know that something exists. And it looks like I also forgot to save my handle ornament. So let's save that one. Or oh no, I did save my handle ornament. So yeah, but now let's get back to this. So get back to your handle with ornament file, and then there should be an error. If you haven't already inserted this hammer handle, you should not have this error, so don't worry. And it should say one component is out of date. That just means that you have made some save or you've done something different to a parent file, and now we need to correlate it. So what we're going to do is we're going to make that correlation happen by clicking this paperclip or that link, whatever. And once you click it, then my screen turned entirely gray, which tells me that my hammer handle should be in my assembly. There we go. So as a review, what we did was we clicked this, and then we right-click here. Then we click Insert into Current Design. Make sure everything is saved before you start an assembly, right? So yeah, your file should end up here. And now we're also going to insert our handle ornament using the same method. So right-click and then Insert into Current Design. 1 second, and there it is. Right, and you can move it around with like this middle part, and you can rotate it in all the different axes. It's kind of fun if you want to just play with it, and you can move it around in one way or another, but you know, yeah. Oftentimes what will happen is like if you have a big assembly, you'll put something in your assembly and then it'll be like entirely at the different corner of your assembly, so you won't know where it is. And what you'll have to do is you'll have to like go to your components and then click like find component or go to component over here, and then you'll find out where it actually ended up. But we have a small assembly, so we're lucky. So once you know you have positioned it, which is not really important. And now we need to join these things together. So what we're going to do is we're going to click Assemble. And when you click Assemble, this menu should pop up called Joint. And there should be two types of, there should be two things over here, component 1 and component 2. As a general rule, let's say you have, you know, two things, and component 2 is located at some position, component 1 is located at some position. If you click component 1 as like my left hand, and component 2 as my second hand, when they join together, component 2 is going to stay still in its position. It's not going to move. Component 1 is going to be the one that's going to float over and join. And over here in motion, there's a bunch of different types of motion which are relevant for different applications. So rigid is like when two things are like welded together, like there's literally no motion in between them. If like my right arm moves, then my left arm moves as well. in Revolut, that's like, what's a good example? That's like a pencil and a pencil sharpener. Like when one thing will be spinning inside another. Then there's slider, which is like a train on a track. It only moves in one direction at a time. And then there's a bunch of these combination ones, such as cylindrical, pin slot, planar, and ball. So ball is the way, like if you think about like your hip joint or your arm joint, like the ball and socket joint, like it sticks here and one can spin and the other is immobile. But we're just going to stick with rigid for now because we don't want Thor's hammer to be moving around. So click on assemble if you haven't already, and then make sure you're in the position. And I'm going to make component 1 my ornament just because it's smaller. So I'm going to click that. And once you do that, this should be non-colored and this should go to be colored. So component 2 is automatically up for selection. So I'm going to select component 2 to be the top of my handle. And for that, I want it to be like this face over here. So I'm going to click on there. And you might need to double click. Sometimes it works with a single click, but I think with rigid, you need to double click. So it should be stuck on there nicely. And you can rotate it around, but this does not mean that your object is actually rotating. It's just like you positioning it. And this flip over here, I have been messed up by this so many times. What this does is it reverses the orientation of your object. So if I were to click this flip, you're like, oh no, where did my object go? But it's just like flipped on its attachment point. So if your mate or your joint does not look like you want it to, try clicking the flip. So yeah, all right. So I have made this joint and I'm gonna press OK, and there should be the symbol over here. The symbol means it's a rigid joint. And I'm gonna save this using good practice. All right. Has everyone successfully attached their ornament to their handle? You know if anyone's had any troubles? Looks like not. Also use quiet. So then we're going to move on to attaching our handle to our hammer, right? So now I'm going to make another file. So click on, actually, if your guys' computers are like struggling with all the files, you can close a few of them. We're not using them all the time. So yeah. Anyway, after you close, you can make a new file. So the Zoom thing got in the way again. Where should I put it? Down there. And then, so click here, new design. Wonderful. And now I'm going to save this and call this my, I don't know, completed hammer. Yeah, completed hammer. Have you guys seen those memes where like people are editing papers and the first one is called paper and it's like paper final for sure, and then it just goes on from there. That's also, it's a bad habit to get into with CAD, because oftentimes if you like open up a file, you won't actually know what you have changed in it because the change might be like some very small component. So yeah, don't do that. Put like like dates or something else on there. But for now, this just calling it completed hammer will suffice because we're never going to work with them again. Yeah, and so we have our completed hammer, and we want to insert the hammer head first. So I'm going to right click on it, click insert current design, and it should look like so. Then you can just go ahead and press enter unless you want to move it around for whatever reason. And then I want to attach my handle with ornament. So I'm going to take my handle with ornament and insert into current design. Oh, it's like they're kind of inside each other, so I'm just going to move this over here for my convenience. Then I'm going to go ahead and press enter. So now everything is nicely in my file. All right, now I want to put them together. And my general rule is that unless I have like some definite source which absolutely cannot move, I use the smaller component to be component 1 during assembly. But if there's something which you absolutely do not want to move in your file, what you should do is, for example, if I really don't want my Thor's hammer to move, like the hammer head to move, I can click this little arrow and then move my mouse over to like the component's name. And then I can right click on it and it will say ground. So what ground means is that your object will now not move at all. So no matter what you do, even if you put component 1 to be your torus hammer, it won't move. Everything else will move, but this won't move. This is particularly important if you're making like a really big assembly, because if you just have like random pieces moving, it can not only get very confusing because like, you know, you might think, oh, my piece is at the origin, but then suddenly it's not. It's at like negative 550x, negative 20y, and negative 80z or something. So yeah, grounding is a very helpful thing to have. So yeah, and then, oh, not the extrude tool. And now we want to put these two together. So I want to assemble my my whole hammer. So yeah, well, I want to assemble from the bottom, obviously, but right now you may be like, well, I can't see the bottom. So you have to use the orbit tool. So like press down on your cursor. God, I keep calling it the cursor. It's the mouse scroll thing. So use that to scroll, and so you can see the bottom. And then click on the flat face of your object. Okay. And then press home. And we have selected our component 1. And if yours, for whatever reason, doesn't automatically go to component 2, you can click, where it says snap, then you can click on this, select, and nothing's selected yet, but I'm going to select like this inside face to be the joining point. And okay, right now, don't freak out. If your ornament got left behind, don't freak out. The way Fusion does assemblies is that if it's like a multi-assembly piece, it will move over whatever you're mating, and then once you click OK, the rest of your pieces will like follow with it. It's kind of cool if like if you have a really big assembly, because you have like all these pieces being left behind and they just kind of zoom over. So yeah, right now your handle should be here, and it's flipped. And now it's broken, so I'm going to leave the flip on. So yeah, so once it's positioned here, I mean, you can rotate it and you can do some positioning with it. And again, for my motion, I'm going to set it to be rigid. So, okay. And there we have a very rudimentary torus hammer. Has everyone kept up? Have we lost anyone along the way? Did anyone's fusion freeze? Did anyone make a different ornament? I'm curious. All right. If not, then we have 5 minutes actually. I can show you guys like what I have worked on for my active water treatment project, because then you can like kind of understand the scale that CAD can work at. So I'm gonna go to my shared team drive, so AWT. And oh, again, look at me not saving my thing. So Control Save once you've done your completed hammer. Okay, so after that, I'm going to go to my AWT team drive. It should have saved. Okay, save, user save, yes. Okay, then. Give it a second because our drive is very big. And under the AWT, whoops, I'm going to go to, come on, share with me. And admin, don't worry about all the structuring, but this is like the current build for AWT. And I think currently it has like 50 some components, if not more. It'll take a while to open. It's a hefty file. So this is our current build. And as you can see, it's got a lot of different components to it. And once you're experienced with CAD, you can also start like making these bendy things, which are kind of fun to make. I mean, they're really frustrating at times, but you can start making things which are bent. And yeah, so right now you might be wondering, well, how do I know that everything's on the same level? What I have done is I've kind of cheated a little bit. I have made what I called an earth. Oh, where is it? Oh. Nope, I don't want to see the joints. So yes, I have made basically like a big rectangle, which I always like make it invisible. so that when we like, take our lovely screenshots and whatnot, you can't see it. And I've kind of cheated by doing this, because what it allowed me to do was I set this to be my ground, and then I was able to make all my measurements and joints in reference to this ground. And I even made it like concrete gray to match the color of the garage we work in. But it's very, very useful. So CAD, this whole thing has been made by CAD. It's taken us a while, but yeah. So very interesting. And then these are like all the little connectors I was telling you guys about earlier. So there's 1, 2, 3, 4. So there's 5 connectors, right? And these are all separate CAD files, because when I change one, I don't want to have to change my whole file. So yeah, that's like the power of CAD and Fusion 360. So the neat thing about Fusion 360 is that we can have like lots of people in one drive and not one drive. It's not a drive, in one cloud team. They have some funky name for it that I don't know. But yes. No, I don't say. All right. I think we're nearing to the end. Does anyone have any questions like about CAD or anything else about Fusion? Wow, you're all a quiet bunch. Either I did a very good job of telling you what to do, or you're so far behind that you're still catching up. Like that happens to me in classes where I'll be, like the professor will be writing on his tablet or like on his presentation, and then he'll say, "Do you have any questions?" Then I will still be like 5 slides behind them, and then I'll say, "Well, I wish I did." So yeah. Okay, let me go back to my final hammer. All right.
I can go ahead if you're all done, Animesh. I can.
Yeah, I'm all done. Doesn't seem like anyone has any questions or issues.
For sure. If you could let me screen share.
Yep, I'll stop sharing.
Cool. So thank you, Animesh. That was incredibly informative and concise. Lovely. So I hope we were all paying attention, because we're all going to put the skills we just learned to the test and build something of our own with some parameters. So let me share screen really quick.
But you'll have a tabletop, and then you'll have legs to go into the table, and you will also have to make a little foot to go into the table so it doesn't scratch your nice hardwood floor. And you'll need to have 4 legs and a tabletop. We don't really care that much about the dimensions of the tabletop itself, or the legs for that matter, but we do want it to be like a 4-legged table. And if you're extra ambitious, you're also welcome to go ahead and design stuff to put on the tables, like pencils and cups and whatever you want. And then we will be presenting everyone's creations later. So yeah, the way you read these diagrams, I zoom in. Anyway, so I apologize for how small this is, but if you see this 1.8 over here, that means the inner diameter is 1.8 and the outer diameter is 3. And the height of the bottom part of the foot is 0.5 inches, and the height of the top part is also 0.5 inches. And here's an isometric view showing you the whole object. And here's the leg that we have done. The height is 28 inches, the inner diameter is 1.8, and the outer diameter again is 2. And finally, here's the table. And in the table, each of these like slots for the legs, they are 2.25 inches from each side. And the dimension of the table is 50 inches by 20 inches by 3 inches. So yeah, you'll be able to see bigger versions of these files with the QR code scan. But yeah, I think your guys' time begins now. So if anyone has any questions, either let me know in the chat or you can like speak up. So yep, good luck, y'all.
All right, I'm going to turn off my video because my computer is struggling. Apologies. All right. So welcome back, everyone. Actually, let me pause the music. As lovely as it is. Hopefully, everyone had a very informative and fun experience learning from our wonderful hosts, and that we all kind of got to apply our skills with our table building as well as any other extraneous things we decided to put on. That being said, if anyone at this time would like to kind of show off what they've made, whether that's just a basic table that you're particularly proud of, or if there's anything that you like managed to create that goes on top of the table, that would be lovely. Feel free to shoot in the chat or speak up, and you can go ahead and screen share whatever you've made. Who will be the first brave soul? I'm sure whatever you have is wonderful, friends.
I can share mine. Just I kind of combined something I was working on for PWT on the table. So just
Nice. Go ahead and screen share.
Yeah, I think yeah. Here we go. So here's a table with a burette and some flask and a stand. So yeah, apparently you can combine multiple assemblies into one. And so I just dragged this whole thing and put it on top of the table. Yeah.
Classic. Take me back to like physical lab classes. Holy crap. Yes, if only we had the table IRL. I'm about to like live the rest of my life in quarantine in like SolidWorks and Fusion 360 and just like build campus.
Nice.
Like people who do that, they like do art in like these CAD programs. It's crazy.
Insane, yeah.
Jaden, go ahead and show us what you got.
All right. Can I see that? All right, so this is my table. I put Thor's hammer on top of it, and also this thing that I've made previously. It's a little, wait, the zoom controls are in the way. It's a little stand that I put a candle on top of. And so yeah, this is my table, my Thor's hammer, and my candle stand.
Love it. Wow. So simple adding the hammer that we worked on as our little example. Brilliant work, Jaden. Very smart.
Thank you.
I think after us learning this much information, I think we'd all be worthy enough to lift Thor's hammer. That's just my opinion. Anyone else got anything rad to show to everyone? I understand that it wasn't the longest amount of time, so I apologize for expecting folks to go above and beyond. We know we kind of squeezed the time, but we'll know for future reference. So I guess thank you for those of you who shared. We will be trying to post some things onto our website. I don't know if we're just going to take screenshots from this video recording or if we're going to end up reaching out to you, like send an export of like a PDF or something of the file. So just hold on to that. We may reach out to you in the next day or so about that so we can show your beautiful creations to the world. Okay. It's going to be question and answer time now. So, I mean, if you want to keep working on your various things, you can. But ultimately, this is just set aside time. So if you have any general questions about either program or CAD software in general, or like further applications or what you can do with CAD ultimately, this is the space for those questions. And Animesh and Arturo, you can trade off or whatever the question is specific to your given software. But any questions, feel free to speak up or drop them in the chat.
I have a question. So like if you're really good at like one type of CAD, let's say Fusion 360, how easy is it to switch over to something like SolidWorks?
Oh, you go ahead.
Okay, I just saw your mic pop on. But really, it's very easy because I learned CAD initially in SolidWorks, and yeah, and then like midway through high school, we moved. So in my other high school, they were using Autodesk Inventor, which is like Fusion but a bit different, and I had almost no trouble switching. And then from Autodesk Inventor, I'm now on Fusion, so it's really not hard. It's because the terms and stuff they might use might be a little bit different, but the functions and the animations are often identical.
Great question, Jaden. Anyone else?
Weird question, but how do I delete something? I don't know if you went over that.
Oh, you're on Fusion, right?
Yes.
When you say delete, do you mean like delete something from an assembly, or like from a
like I added an extra leg to the table. Like it's just
okay.
like, how do I just get rid of that?
Yeah, that's not a problem. I can just quickly share my screen. So where's my completed table? Here it is. So when you're over here, you have your components in your assembly listed along here. And then if you want to delete one of them, you can right click on that, and then there will be a delete. So if I were to delete that, it'll give you something like this: features, reference by other features. Do you want to continue? You can click go ahead and delete. It might give you a bunch of errors, but if it's just an extra thing, it shouldn't be too bad.
Okay, and then another question, like my table right now is like upside down, or how do I flip it? Or is it just a rotational view thing?
Can you share your screen so that we can see what you mean? I think it might just be your view. Like, yeah, unless you grounded something, there's really no like.
Oh yeah, I didn't know how to ground either, so I don't think I did that. It's just like this. See how it's upside down?
Oh, I see what happened. So yeah, I think the holes for your table, like they are on the top of your table, because in your when you were drawing the table, I imagine you put like the holes from your top view. So it's just that the holes for the tabletop are on the top of the table.
Oh, I see. So when I was here.
Yeah, that's why it looks weird. But if you were to put the holes on the bottom, it wouldn't look like that.
Okay, how would I go about putting the holes on the bottom?
So if you want, you can just go ahead and delete the holes you have right now. Yeah, you can just do that through either through the timeline or through the sketches, whatever. And yeah, so but basically what you would do is you would have like a solid brick for the tabletop, and then from your bottom view, you would put in the holes, and you can dimension them all at once, so it's less trouble.
Okay, so it's bottom view rather than top. Okay, I see.
Yes.
Thank you.
Yep.
Great question, Dahlia. Yeah, so as you can see, we get to ask questions either. We have like a solid amount of time set aside for Q&A. So you can ask any questions either they're specific about the design that we were doing, or if they're more broad about CAD software in general, anywhere in between. I actually have a quick question. It's more like personal to you. You host folks, but what is the most like complex thing that you've made in CAD, and what made it like difficult and or fun and or annoying to make? You can have Arturo answer first.
Sure. So I'm in a solar car, ESW solar car, and as an engineer, mechanical engineer, we had to kind of go through all of the old files that they had and kind of redesign them. And the ones that I was in charge of, I had to kind of remake the chassis of the whole car. So like working with those 3D drawings and kind of having pipes all over the place. That was pretty challenging, and also working with the suspension of the car and kind of assembling all of that. And I'm trying to, like, all of that is on the drive, and sadly, I had to format my laptop since. I'm trying to look for the old files and see if I can open the assembly, and I'll let you all know.
Funnily enough, mine is also car related. So in high school, we were doing like this design competition, and we had come up with this kind of new driving system for a car where instead of like an engine driving wheels, you would have, if you guys know like the toy Sphero, it's like a ball which you can like control with your phone and it drives around. We basically wanted to have an independently driven wheel for like each corner, and they had to fit into what's called a caster bearing. And yeah, the caster bearing, it's like a looks like a hat which sits on the ball, but it had to be tight enough that the ball would sit on there, but not so tight that it would like hinder the motions. And then you like CAD the balls and the parts inside them. It was just awful. And also my computer was slow because it was like a school laptop. So I actually, that's a very big challenge in CAD. If your computer starts like lagging or something.
Very nice. Damn, I cannot imagine doing CAD stuff on that scale. But I guess like once you get the individual parts down, it like the skills naturally scale with the scale of the assembly. But yeah, any other questions?
How long does it take to become proficient and like sufficiently proficient, I guess, to make like a actual project for a class or, you know, for actual use?
I think I've only really had like 2 classes in UCSD where we had to use them, being like MAE3, which is like the intro design lab-ish class where you had to make like a robot and like a clock thingy. Then last quarter I actually took another class, but the thing that helped me the most was like being in projects, and like especially being like in that solar car project. I think you just sit down and try to like find examples of people that do similar stuff, and you just kind of use all of that stuff for inspiration. The more you practice, of course, the better off you'll be. But hopefully, with what we went through, you'll have like the basics, and you kind of get a better understanding of how to like turn 2D stuff to 3D. So, yeah.
Yeah, and they actually also offer certification courses for both of these software. And if I remember correctly, they're about 100 hours. I don't know like the exact time length for them, but you know, they're usually about in the range of 100 hours, I would imagine. So if you want to define proficient as in like Autodesk and SolidWorks acknowledge you as being good in that software, I would say it's about 100 hours because that's the length of the course. But like you can do a lot just with really basic skills, because oftentimes the point of CAD is not to have something with which you can do like flow simulations or like impact tests. A lot of times it's to make like a computer model of something in the real world so you can work with it. So I would say like 30-ish hours where you spend tinkering, just, you know, figuring out the functions and doing some stuff on your own, you could be pretty good if you keep yourself to your strengths. So yeah.
Yeah, I would say I'm not sure if it's offered for the nano department, but we have this thing called a solid professor, and it gives you like it just gives it goes through the entire SolidWorks AutoCAD Fusion, and you actually get certified for completing like their tutorials. Well, something's trying to open. Yeah, so I believe I'm not sure. I think it was around like 7-8 hours for basic. Like for proficiency, as you said, Joy, and just for like advanced, it's like additional like 8, 9, 10 hours, and that's just for the certification. So Solid Professor is a really good one, and YouTube, people all over the place upload everything to YouTube. So if you kind of want to like model fun stuff, someone has probably already done it, and if not, someone's probably done something similar. So you could just always look that up and kind of go from there.
Great. There was a question in chat opposite to my question, which is, what is your favorite / easiest project you've ever done? You can go Anima and then Arturo.
The easiest thing was a pipe, because I'm an AWT and a lot of our stuff is just pipes. So you make like one pipe, and then you just make different lengths of that. So I would say like a pipe or a pipe assembly.
I think I just make like random stuff, or I used to when I was learning. I made like a stand for my Switch that 3D printed, and I just like put it on there. I don't know, I made like a Pac-Man thing, like some chess pieces. I'm just gonna screen share once more, and this is kind of what I was talking about, a chassis. So this is what it ended up being, and it's just a bunch of pipes. And one thing that we didn't go over, but you can also kind of draw like I know we went over like planes, like really basic, but you can kind of keep redefining planes to kind of sketch like in the air and in 3D and create like pipe-like structures. So yeah, this is supposed to fit a person eventually once Solar Car gets everything together. But yeah, just like a bunch of pipes, and we actually have a physical model of this chassis that we've had to redo. But this is the hardest thing I've had to work on, like redoing the lengths like in between these individual pieces and kind of piecing it all together. Yeah. And of course, if you kind of want to, I forgot there's just a bunch of websites where people upload like their own SolidWorks projects, and now that you have the software, you can kind of open them up and see how people kind of design some stuff if you want to get more practice with it.
I would imagine, like with any software, once you have the basic tools, the best way to learn is to just do. Is to just like find like a simple project, like a table or any other simple, maybe like a small piping system or something, and just trying it. And then through trial and error and aggressive Googling, just like we've all learned MATLAB or Excel and things like that, that's typically how you learn a lot of it. So I would encourage y'all to like pick little projects. Like people have made like, yeah, like fun, weird stuff. Like people, 3D printers are all the rage. Like finding something that in theory, if we were back on campus and envision, like what would you want to 3D print? What could you model in your software? And I think that'd be a really good, strong learning experience to get like a fundamental awareness of what it's like to operate in the specific system. Any other questions? We have like about 1-2 minutes left for questions, and we'll wrap up.
Do any of the CADing software programs work for most companies, or do some companies have more preferences?
Speaking like from what I've learned in class, mostly I think if you know SolidWorks, you should be like fine, and Fusion is also perfectly fine. Like right now, currently, like for my design class, for my senior class, we're using Fusion to model, to kind of prototype a CNC machine, and the CNC machine just cuts a piece to certain specifications, and we're using Fusion 360 to kind of like make the toolpath and cut a machine and simulate that. And SolidWorks is always good to know, but like was mentioned, you can kind of transition between both of them pretty seamlessly, and also Inventor.
Yeah, I think a lot of companies, they will largely use SolidWorks, but if it's something like international collaboration, Fusion does have the strength of it being cloud-based, so it's much smoother to share files and to share, drawings and stuff.
Nice. All right, we will wrap up here really quick. I'm just gonna share a screen and share these slides. Hopefully our my laptop doesn't break. So one quick business announcement for the quarter from AIChE Projects Leadership is AIChE Projects Leadership's applications. They're due, I believe that's this Friday, the 26th. You can scan the QR code for the Google form. It's also all over in the Slack. We're looking for assistant program director, assistant program manager, assistant research coordinator. All of the information is on the form, but of course, if you have any further questions, you can check our website, check the Slack, or email us at aicheprojects@ucsd.edu. aiche.ucsd.edu, I think is our email. But yeah, that's due very soon. It's a great opportunity. I'm biased, but I think it's a pretty cool job. And other than that, that's all. If you haven't signed in yet, please sign in. There's a QR code. Thank you to Animo and Arturo for being amazing, amazing hosts and mentors, for volunteering their time. And to all you folks who set aside time to join us today. I wish we could do this physically in a lab, but we all went out of our way to have a similar analogous experience over Zoom, and I appreciate it. So yeah, thanks to our hosts. Thanks to everyone for coming.